This video is just from the GCSE perspective, talking about embedded systems. So an embedded system is just a device that has a computer system built into it. So to get 2 marks on a question like what is an embedded system, you have to say that it's a computer system that's built into a physical product or device with a dedicated purpose. So there are 2 marks there, the dedicated purpose bit and the computer system that's built into a product or device. So it's not enough to say something like it's a system in a system. If you say that, it won't be enough. You'll get an any, not enough on your exam for that. So you won't get any points for that. So don't say things like it's a system in a system or something that's kind of vague. So the 2 marks are for an embedded system, a computer system built into a physical product or device with a dedicated purpose. So we're quite familiar with these products. So we've got loads of them around the house. So they could be a DVD player or a TV box, a microwave. Toasters are often embedded systems these days, and washing machines. So in fact, very many of our consumer electronic goods are embedded systems. So embedded systems, just like any other computer system, has an input, a process, and some storage and output. So that's what makes it a system, just like any system. It's just these inputs are slightly different to our traditional computer. So there's normally no mouse, there's normally no keyboard, but we might have other things like buttons. There might be a small display or some lights, that kind of thing. So often these are run by microcontrollers. So a microcontroller is a computer on a single chip. So it contains everything: memory, processor, input and output pins. And so these are ideally suited for running an embedded system. So often these systems run differently and they use memory in a different way. So ROM, read-only memory, can often contain the programs and the data to use with them in an embedded system. So normally in our computer we talk about RAM holding the programs and ROM, things like boot up or bootstrap programs. But in an embedded system, we don't really need very much RAM. There might be a tiny bit, but we don't really need very much because there's not very much data to store. So if you're thinking about running a washing machine or something like that, there are a fixed set of programs, just a fixed set of programs. So those programs, they don't change. They don't really have any requirement to save data. So we can get away with having most of the programs in a ROM, a read-only memory, and hardly any RAM, if at all. So that's another point that we can use in a question that says what's the difference between embedded systems and general purpose systems. So they use very little RAM or none, but often more ROM. So it's usually the other way around, because sometimes you'll get a question saying, is there more RAM than ROM in a general purpose computer? And the general answer to that is yes. But in an embedded system, that's often the other way around. So another thing to think about is that they're often space restricted because the system's built into another device. It's not necessarily the main bit of that device, and the device might be quite small. So they tend to use solid state memory. It's not very often to have a hard disk. Obviously, if you've got a TV recording device, that might have one still, if you still use that kind of thing. But mostly solid state devices, because they're reliable, they've got no moving parts, and they take up less physical space. So that's often the secondary storage if there's a need for it. So an example of a couple of examples of an embedded system. One could be a washing machine, another microwave oven. They're both domestic appliance device. Some buttons probably for the user interface. You might have a button or a dial that you turn to set the programs. Same goes for the microwave. You might have a dial to set the time, or you might have built-in programs. And they form the user interface along with a small display that shows the current program or an error message or something like that. So things like the door release and the motor are controlled electronically by the system. So those devices are output devices, things like the motor. It's an output, and they're controlled directly by the embedded system. So embedded systems often have sensors that bring information into the system. So instead of it waiting for information from the user, they get information from the environment. So an example might be a car. It has sensors for wheel speed, outside temperature, perhaps engine temperature, lambda for gas sensors, a fuel sender that says how much fuel is left in the fuel tank, and lots more. So ABS and all kinds of things. So those sensors are input devices that feed data into the system so that it can then adjust the outputs. And outputs for a car, car kind of outputs, well, they might be the amount of acceleration, the speed that's desired, perhaps the amount of petrol that's being put in. There's an output when the brakes are applied. So especially in a car that's got elements of self-drivability or adaptive cruise or something like that, some of those outputs can also be automatic. So in our embedded system examples, we can make any example we like that's usually a domestic appliance. We should remember that it is a computer system built into a physical product or device with a dedicated purpose, and you get the second mark here for the dedicated purpose. We should also remember that it uses very little or no RAM, but often more ROM than RAM, so it's unlike a general purpose system from that perspective. And if we can remember those two things, then we're well equipped to answer most exam questions about embedded systems.